In this video, we'll take a definition for the variance. If x is a random variable with a probability mass function of f of x, it then means that the variance of x is equal to the expected value of x minus mean all squared. This is the definition of variance, and it can be written as the expectation of x squared minus mu, where this is the mean. The variance of x can also be written as the expected value of x squared minus the expected value of x all squared. Now, how can we compute the expected value of x and the expected value of x squared? The expected value of x can be computed using the summation for xi's x multiplied by f of x, while the expected value for x squared can be computed as x squared multiplied by f of x. So this is how the variance can be computed, and this is the definition for the variance. Variance of x is equal to the expected value of x squared minus the expected value of x all squared. So with this, we can easily compute the variance of a random variable. With this formula, we can easily compute the variance for a random variable. For more on this topic, you need to subscribe to this channel. So the variance for a continuous case, for more on this topic, you need to subscribe to this channel. We have this as our variance, the expected value of x squared minus the expected value of x all squared. You see? Now, the expected value of x for the continuous case, that means the expected value of x for the variance of a continuous case is equal to the integral of x multiplied by f of x dx, while that of the expected value of x squared will have the integral of x squared f of x and dx. So we can simply write the variance for the continuous case to be the integral of x squared multiplied by f of x dx minus the mean squared. Or we write it as the integral x squared f of x dx minus minus the integral for x multiplied by f of x dx. So this is how we can write the variance of x for the continuous case. So for more on this topic, you need to subscribe to this channel. So if you're using this, you have to look for your integral value and now do the subtraction. The same thing appears here. So this is just the definition for the variance of the continuous case. While this is the variance you can say for the discrete case. For more on this topic, you need to subscribe to this channel.